Lesson 6.6 is kind of fun. We're going to look at fractals and self-similarity. You'll learn to recognize and describe the characteristics of fractals and identify non-geometric iteration. How is mathematics found in nature? Patterns can be found in many objects in nature, including broccoli. If you take a piece of broccoli off the stalk, the small piece resembles the whole. This pattern of repeated shapes at different scales is part of fractal geometry. Manuel Mandelbrot, a mathematician, coined the term fractal to describe things in nature that are irregular in shape, such as clouds, coastlines, or the growth of a tree. The patterns found in nature are analyzed and then recreated on the computer, where they can be studied more closely. These patterns are created using a process called iteration. Iteration is a process of repeating the same procedure over and over again. A fractal is a geometric figure that is created using iteration. The pattern structure appears to go on infinitely. Compare the pictures of the human circulatory system and the mouth of the Ganges in Bangladesh. Notice how the branches of the tributaries have the same pattern as the branching of the blood vessels. One characteristic of fractals is that they are self-similar. That is, the smaller and smaller details of a shape have the same geometric characteristics as the original form. The Sierpinski triangle is a fractal that is self-similar. Stage 1 is formed by drawing the mid-segments of an equilateral triangle and shading in the triangle formed by them. Stage 2 repeats the process in the unshaded triangles. This process can continue indefinitely, with each part still being similar to the original. The Sierpinski triangle is said to be strictly self-similar, which means that any of its parts, no matter where they are located or what size is selected, contain a figure that is similar to the whole. Example 1, draw a square. Create a fractal by bisecting the top left side of the square and drawing a smaller square inside the larger square. Okay, this would be stage 1, and then we could continue the process forever and ever, repeating the same pattern of bisecting the top left side. Now they ask us to draw an equilateral triangle. Create a fractal by drawing another equilateral triangle within it and shading above or beneath the triangle that shares the horizontal side of the triangle. Stages 1 and 2 get us started, but once again there is no stopping us. We could continue the process forever. A famous fractal, if we start with an equilateral triangle and keep trisecting it over and over again, is called Koch's snowflake. Okay, now we're going to work with numbers and iterations. They want us to find the value of 3x squared minus 1, where x initially equals 1, then use that value as the next x in the expression. We're going to repeat the process 3 more times and describe our observations. This is a great use of the memory that your calculator contains. Okay, we don't need a calculator for our first evaluation. When we substitute 1 in for x, 3 times 1 squared is 3 minus 1 is 2. And then we substitute 2 in for x. 2 squared is 4, times 3 is 12, minus 1 is 11. Okay, at this point I want my calculator. 3 times 11 squared minus 1 is 362. Now, if I take 3 times last answer squared, because 362 would take a lot of typing, minus 1, I get the 393,131. Now that, I'm going to want to use the last answer button if I wanted to do it again. Okay, they ask us to describe our observations. Here, if we kept going pretty quickly, the x values will increase, and pretty quickly we're going to get really huge with that squaring. They're going to approach infinity. And we could write the infinity symbol if we want. Oh, that's terrible, but you know what I mean. The diagram represents the odd integers 1, 3, 5, and 7. Find a formula in terms of the row number for the sum of the values in the diagram. Okay, so we've got 1 plus 3 is 4, 4 plus 5 is 9, 9 plus 7 is 16. Those numbers, 1, 4, 9, 16, I've seen them somewhere before. It seems to me that 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. So if I want to find the sum, all I need to do is take the row number, which we let be n, and square it. Oh, golly gee, the sum of the first 10 odd numbers? Oh, what shall I do? Oh, that's right, we have a formula. All I have to do is take s sub 10 equals, plug into the formula, 10 squared is 100, and that is much faster than actually adding the first 10 odd numbers together. Blaise Pascal did not discover Pascal triangle, but it was named after him in honor of his work in 1653 called Traité on Arithmetical Triangle. The patterns in the triangle are also used in probability. Okay, the famous Pascal triangle starts with a couple of ones, and then if I have this started, I can keep going forever. I don't want to steal your joy and tell you how I'm getting my numbers. I'm going to ask you, look at this pattern. Where are the numbers coming from? I can go on and on and on forever. Oops, forgot a 20. Nope, that was a 15. And that's a 6 and a 1 on the outside. Okay, can you see where the pattern's coming from? Okay, Jacqueline has $1,500 in a savings account that earns 4.1% interest if the interest is compounded annually. Find the balance of his account after 4 years. Okay, this is a great use of, again, the memory function of your calculator. We're going to start off with, he's got $1,500. And then he's going to get interest on that. So we're going to take his $1,500 times, let's use a parenthesis, 0.041 when we change the percent to a decimal. And we get his new total starting next year. He'll have $1,561.50. So we start off the year with that amount, and we're going to take that amount times 0.041, and at the end of the second year he has more money, $1,625.52. Of course, we're rounding to the nearest hundredth because we're dealing with money. It kind of makes sense. So he's starting off the new year with that, and then he's going to get interest on it. Times 0.041, and at the end of that year, he's got $1,692.17, and he starts off the year with that. And we take that amount and we take it times 0.041, and at the end he's going to have $1,761.55. In summary, iteration is the creation of a sequence by repetition of the same operation. It could be pretty and artistic, or it could be financial like money. A fractal is a geometric figure created by iteration. An iterative process involving algebraic equations is a recursive formula.